Okay guys, welcome to another video from Mathematics World. So in this video, we will see two different approaches to how to find partial r by partial x, partial r by partial y, and such things in this case. Now, before going to the solution, we will play a little bit over here, right? So in this case, we are given like x and y vectors, basically x and y coordinates in the parametric form, parameterized by r and theta, right? So x and y are basically functions of r and theta. Now in this case, it's easy to find partial x by partial r, right? Because yeah, you just differentiate this expression for x with respect to r, theta is constant. So if you differentiate r, this will just be 1, so cos s theta. Similarly, sin s theta. Right, similarly, if this is partial x by partial theta, this will just be r sin s theta. If it's partial theta, if this will be r cos s theta. It's easy to find these expressions, right? But we are asked just the inverse of this expression. So guys, think that do you think that like partial r, given partial r by partial x will just be equal to 1 by partial x by partial r? So that means just 1 by this is cos s theta. Do you think that this is true? The answer is no. This is true if this was, let's say, a complete derivative, not a partial derivative. It was dy by dx, then it would be true that it will be equal to reciprocal of dx by dy, right? But this is not true in partial derivative. Let me just show you a counter example. Let's say x is equals to u plus b and y is equals to u minus b. Now in this case, if you want to express u and b in terms of x and y, if you just add those two, you get u equals to x plus y by 2. And if you subtract this two, you will get b is equals to x minus y by 2. Now if you try to find how x changes with respect to u, this is 1, right? But over here, if you try to find how u changes with respect to x, this is 1 by 2. So clearly you see that those two need not be equal, right? Now even in partial derivative, what needs to be equal, like what's reciprocal needs to be equal is, if we have partial derivative of ub, how this ub changes with respect to xy, now this can be reciprocated, right? And if you are wondering how to find this thing, this is basically partial u by partial x, partial b by partial x, partial u by partial y, partial b by partial y. So yeah, this can be reciprocated. So this will basically be equal to the reciprocal of this thing. So this is basically partial x by partial u, partial y by partial u, partial x by partial b, partial y by partial b. So it's inverse, right? Now I'm just showing you that this works, but by the end of this video we'll also give a proof to why this works, right? So yeah, so for that you need to wait till the end of this video. Like first of all, our first approach would be just to use the common knowledge, simple intuition to find it, and later on in the second approach we will derive this formula and also use this formula to find this reciprocals. So yeah, so from partial u to partial x, we will try to find partial x or partial u using this formula. But first of all, let's just go in a simple manner. Okay, so we have found partial x or partial y over here, all of this. So for that, we needed to have x in terms of r theta, y in terms of r theta, right? Now to find this, we need to have r in terms of xy and theta also in terms of xy, and then only we can find these things: partial r by partial x, partial r by partial y, these things, right? Okay, so let's try to see how we can express r and theta in terms of x and y. So first of all, notice that if you try to find x square minus y square, that will just be r square cos h square theta minus r square sin h square theta. And if you take r square common, that will just be cos h square theta minus sin h square theta, which we know is 1, right? So this is just r square. Similarly, if you try to take uh, y by x, that will just be r sin s theta by r cos s theta, that will just be tan s theta, right? So theta is just tan h inverse y by x, and now we are good to go. So we got that r is just x square minus y square, and theta is tan h inverse y by x. I can also write that as tan h theta is y by x. Okay, so we got this, and now we are good to go. Now we are good to find this. Okay, so using the first equation, if we try to find partial r by partial x, this will just be 2x, right? Yeah. Now if I try to find partial r by partial y, if I try to find partial r, but this is too simple, right? Is partial by partial x really 2x? Well, I did it before. I thought it was a bit complicated. Let me check the answer, guys. Wait, so that I can verify myself that it's right. Okay, so partial r by partial x. Oh, over here it's x by r. Okay, so how is it how is it different, guys? Oh yes. Okay, guys. The reason it differs is because r is not x square minus y square. R square is x square minus y square, right? Okay, so that is the problem, and I'm sorry for that. So now if there's r square, now if I'm like trying to differentiate this equation with respect to x, right? So partial differentiation with respect to x, so this will just be 2r times partial x by partial 2r times partial r by partial x is equals to 2x. So partial r by partial x will just be 2 to cancel out x by r, right? Yeah, so we got that. Again similarly, if I do the same thing, with this equation, if I make a partial differentiation with respect to y, again this r square will just become 2r, and then partial r by partial y will be minus 2y. So partial r by partial y will just be minus y by r. So we got these two expressions, right? Partial r by partial y is minus y by 2r. This is x by 2r. Okay. So now after we have these two, now we are ready to go to theta. So we also know that tan as theta is y by x, right? So let me make a partial differentiation with respect to x. So this will just be sec h square theta. Okay, is it sec h? Yeah, it's sec h. Theta divided by partial theta by partial x, and this will be minus y by x square, right? And now if I take sec h square theta to other side, this will just be partial theta by partial x is equals to minus y by x square cos h square theta, right? And now we know that cos h square theta is just x by r, so this will just be minus y by x square times x square by r square, so that's just minus y by r square. So this is our what is this? This is our partial theta by partial x, right? Okay, this is our partial theta by partial x. Okay, now next is we have to find with respect to y. So again, if we make a partial for this one, if we make a partial differentiation with respect to y, this will be sec h square theta partial theta by partial y will just be 1 by x. So partial theta by partial y will just be 1 by x times cos h square theta. So this will just be partial theta by partial y will just be, now cosine theta is x by r, so this will just be x square by r square, so this will just be x by r square, right? Yeah, that's the answer. So we found out all these four things just from the different equations, right? We try to change like x, we try to change the form. First of all, we had x in terms of r theta and y in terms of r theta, right? And now we changed it into the this form, r as r of xy and theta as of xy, and then we found all of these four equations, four like partials, right? So this is definitely one of the way that you can approach this problem. But now let me show you the different way using this approach, right? First of all, let me show you that this approach actually works, right? And then after that, I will show you why this approach works. So now in this approach, what's like, first of all, let me tell you how do we change this form to the matrix form, right? So basically, if you have partial of AB with how partial of AB respect within with respect to partial of CD, then this is just defined as the like 2 by 2 matrix because there are two elements, and in the top we will just have these elements of numerator with respect to first, I mean with respect to this first element and denominator, we will have partials of element in numerator, right? And similarly, again with respect to second element, now the partial of the numerators. Okay, this is D not B. Partial of D by partial B by partial D. So I think you got it right. Now similarly, if you have, let's say, partial CD divided by partial AB, again we will have the partial of CD with respect to the first element in denominator, right? And again we will have partial of CD with respect to second element of denominator. So this is how this operator works. And now I have told you that just like in single variable, just like in single variable calculus, in multivariable also this holds true. Even though it doesn't hold true for individual partials, this common partials hold true. So that means over here, since these are reciprocals, I can definitely say that this first one is just inverse of second one, right? So which are because this is in denominator, so that means it's inverse, right? Because if there's like matrix 2 3 4 5, this is same as the inverse of 2 3 4 5, right? Yeah, so that's how it works. So therefore these two are the inverse. Now over here also, if I use that over here, now we can easily find this 4, right? You can easily find this 4, and from this 4 you can find other 4s from this 4s. So let us see how we do that. Now to do that, like I have already, we will use the same notation, that partial of r theta. Okay, we don't know, we actually know partial of, we actually know how xy in these four equations, we actually know how xy changes with respect to r theta, right? And using this we want to find out how r theta changes with respect to xy, right? And you can see this as this last element going to numerator, so these two are basically same. Now we know that this is just a matrix partial x by partial r, partial y by partial r, partial x by partial theta, partial y by partial theta, right? I already told you why this works, how this works. About why we are going to do in the next few seconds after we complete this, but about how, I think you are already good with that. Now again, this is just inverse of okay, now we know that this is just inverse of this thing, right? It's just inverse of this thing, right? And that will be equal to partial r by partial x, partial theta by partial x, right? And then partial r by partial y, partial theta by partial y, right? Okay, now let's try to do it. So okay, now to do the inverse, right? Okay guys, but over here, since we need to find this matrix, so we can actually also reciprocate both the matrices, so that This has no inverse and this has inverse now, right? I'm just trying to reciprocate. I mean, if you don't understand, like now if I take the inverse in both sides, if I take the inverse in both sides, now this will have the inverse and all this will not have, right? Dx by dr, dy by dr, dx by d theta, dy by d theta. Now this will have the inverse and all the will not have, right? Because I did that just because we need to find this matrix over here, and like that whatever we need to find, like it's difficult to reciprocate because the values are unknown, right? I hope you get that. Now we know that the elements of this matrix, this is just cos as theta, and then sine as theta, r sine as theta, r cos as theta will be equals to partial r by partial x, partial theta by partial x, partial r by partial y, partial theta by partial y. And it has an inverse. Now to find the inverse, you know the drill, right? Just take the determinant. If you don't know, the inverse of a b c d will be 1 by ad minus bc minus d minus a bc, right? This is it, right? Or am I wrong? I think I'm wrong because only for the second one there would be a minus sign, not for the first one. I'm sorry. I'm wrong. I guess I'm pretty sure I'm wrong. Guys, so okay. So originally how we do a like n-dimensional matrices. First of all, for this one, its determinant is just d. For this one, I mean, yeah, its cofactor is just will be minus b. Its cofactor will be minus. Its cofactor will be a, and we need to take transpose of that. So this will just be okay. A d minus b minus c. Okay, guys, sometimes happens. Okay, yeah, this is it, right? Okay, even if I have done wrong later on, I will correct it because I know the things. Okay, now this is just 1 by r cosine square theta minus sin square theta, right? And we know that that won't change, guys. Guys, I guess I need to look up how 2D inverse works. Wait, I'll just Google. I'm sorry for this. Hydrogen at the rate of 5 Okay, so inverse of a 2D matrix. Images. Okay, guys. DA. Oh yes. Okay, guys. If I take transpose, they won't change, right? So that was the problem with me. Okay, so this is DA. Yeah, good. So these two intersections and all main diagonal intersections and second and like other diagonal. All the diagonal also intersections, no. Guys, again there is a problem over here. If I take transpose, this two will intersect actually, right? Yeah, so the only thing happens is main diagonal is interchange and the other diagonal just the sign is there. Whew. So this is r cos theta. Finally I'm right. Finally the answer matches with my answer key. Okay, so yeah, r cos theta minus sin theta minus r sin theta. So we got this, right? And this is partial r by partial x, partial theta by partial x, partial r by partial y, partial theta by partial y, right? Okay, now, but this is not the same answer that we got earlier, right? We got some different answers earlier. Our answers were in terms of x and r. So let's try to do that over here as well. So if you want to find it in terms of x and r, now this one is just 1. So now first there's 1 by r, which we will divide on like all of these terms. So this is cos theta minus sin theta by r minus sin theta cos theta by r, right? and this is equals to partial r by partial x, partial theta by partial x, partial r by partial y, partial theta by partial y. Okay, now if I want to take this in terms of the x and r, we know that cos theta is just x by r, that's just minus y by r square, because sin theta is y by r. Now this is minus y by r, this is x by r square, right? And this is equals to partial r by partial x, partial theta by partial x, partial r by partial y, partial theta by partial y. So now if it's just using the equality of matrices, we can compare the elements. So partial r by partial x is just x by r, partial r by partial y is just minus y by r, partial theta by partial x is just minus y by r square, partial theta by partial y is just x by r square. And that's exactly what we have got earlier. Maths never lies, guys. Maths never lies. Maths always same. So, if you wanna check, yeah, that's it. Okay, so we got the same answer, right? And this was a pretty good way. Like this also gives an idea about, yes, the derivatives are in fact fractions. If it's about total derivatives, I mean the entire change derivative, then it's just a fraction, because it worked, right? Because this was about entire change in xy with respect to entire change in r theta. That worked, right? Though partially don't work, here also the entire change worked, right? So yeah, it does work. Like it's almost the same as normal fractions. Okay, now this is, I gave this like theorem or formula just based on like intuition, right? Now let's try to get a rigorous proof of this statement. Now let's try to get a rigorous proof. Okay, guys. Okay, now we want to okay. So what I'm trying to do now is, okay, we are trying to search a rigorous proof, right? Okay, so let's say x is a function of r theta and y is also a function of r theta, right? So in that case, if we use the multivariable chain rule, we know that the small change in dx is going to be the change in dx caused by r plus change in dx caused by theta, right? So this is just the partial rate of change of x due to r times the amount of change in r, due to which we get the amount of change in x due to theta is due to r, and this is amount of change in x due to theta. So similarly, we also get that dy will be equals to the change in y due to r times dr plus the change in y due to theta times d theta. I mean the rate of change in y due to theta times d theta. So this is amount of change in y due to r, amount of change in y due to theta. So it gives the total change in y, total change in x, right? Now if we try to write this in matrix form, we can write it as dx dy will be equals to partial x partial r, partial x partial theta, partial y partial r, partial y partial theta times dr d theta, right? You get that, right? If you just try to multiply, you will see like why I'm writing this. You can just try to multiply and see, yes, they're almost the same. They are in fact the same. These two statements are in fact the same. To see that, you can just try to multiply and see. Okay. Now similarly, we will try to go reverse. So let's say in this case, r is a function of x and y, and theta is also a function of x and y. Now in this case, again, if we use the multivariable chain rule, we know that dr will just be the change in r due to x plus the change in r due to y, right? Similarly, the change in theta will be change in theta due to x plus change in theta due to y, right? This is just the multivariable chain rule, where the total change, we get it from the partial changes in theta due to x and y, right? So yeah. Now again, if you try to write it in matrix form, we get dr by d theta as partial r partial x, partial r partial y, partial theta partial x, partial theta partial y times dx dy, right? So we also get this matrix form. Now, notice that, notice that if I try to take this matrix to other side, what will happen? So if I do that, I will get dr d theta as the inverse of this thing. Sorry, I'm sorry that my handwriting is getting worse. Okay, so what I'm trying to do is I'm trying to take this matrix to other side. So dr d theta is now alone. So this is dx by partial x partial r partial x partial theta partial y partial r partial y partial theta inverse times dx dy. Right? Now notice that again, these two equations are the same. We have dx dy in the end, dr d theta over here. So that means this matrix and this matrix must be same. So we says that partial x partial r partial x partial theta partial y partial r partial y partial theta, this inverse must be the same as partial r partial x partial r partial y partial theta partial x partial theta partial y. Right? So yeah, now if you now in this case, now if you try to see this matrix, like now, okay, so now if this is same, like now our original statement was slightly different, right? But if this is same, it will also be true that, like, even if these two like elements, even if if I take the transpose, let's say, if, okay, what I mean is, if matrix 1 inverse is equals to n, then the transpose of matrix inverse should also be equals to the transpose inverse. So basically what I'm how this works is you can take transpose in both sides, right? So they will be true, and then now you can take the transpose inside the inverse. So yeah, now if we take the transpose in both sides, we will get the expression that I told you earlier. This is partial x partial r partial y partial r partial x partial theta partial y partial theta. This inverse will be equals to the partial r partial x partial theta partial x partial r partial y partial theta partial y. And yeah, this is exactly what I gave you earlier. So now this matrix is just partial change in xy due to partial change in r theta. So its inverse is just equals to partial change in r theta due to partial change in xy. So yeah, finally we have verified this argument. And yeah, with this verification, all of our problems are solved. So we solved it using induction, we solved it using formula, we also proved the formula. I also give you an idea for the formula, and this is all. So this is the lot. I hope this video was helpful for you. So thanks for watching. Do share with your friends too, and look forward to seeing you in the upcoming videos as well.